Stars lead a hard and challenging life, but as you will see, remarkably similar to your own life. I'm sorry, folks. My colleague has put the wrong film in the thing. Hang on, I'll go get the right film. Here it is. Here we go. Stars lead a hard and challenging life, but as you will see, remarkably similar to your own life. Stars live a lot longer than we humans do. They follow the same or similar cycle to us. A star is born, they grow up, live for many years, then die. The main difference between us and stars is that stars can explode. That just makes their life more exciting. Stars are born in a nebula. A nebula is a build-up of gas and dust that is found all through space. The gas is usually hydrogen atoms and the dust is mostly carbon and silicon. The gas and dust is what make up a star. In nebulas there are varying regions where gravity makes the dust and gas start to clump together. As the clump gets bigger, its gravity increases, pulling more and more gas and dust into it. A protostar is born. A protostar is very unstable. For a protostar to become a real star, it has to achieve something called equilibrium. Equilibrium is a balance. In the case of a star, it is a balance between gravity pulling atoms towards the center of the star and gas pressure pushing heat and light away from the center. At this point, a star has two choices. 1. If core temperature does not reach critical, the protostar will become a brown dwarf. A brown dwarf will never become a star. 2. If core temperature does reach critical, nuclear fusion begins. A star is born. Scientists identify the birth of a star as when it starts fusing hydrogen in the core into helium. A star, well, a star is a very hot ball of gas that has hydrogen fusing at its core. This is what a star does for almost the rest of its life. When the hydrogen is gone, it fuses helium into carbon. The giant stars fuse carbon into even more heavier elements. While this is happening, the battle to keep equilibrium still rages on. Stars live almost all their lives in a phase named the main sequence. Once a star is born, it starts to shine or send energy into space. Because of this, a star slowly shrinks over billions of years. As a star contracts, its temperature, density, and pressure at the core continues to increase. When a star starts burning helium, their time is nearly up. By now, most of the hydrogen in the core is gone. So, to keep equilibrium, a star is forced to burn helium, which is much harder to do. As the helium burns in the core, a rapid hydrogen reaction occurs in the shell of the star. As the shell temperature increases, the outer layers expand. When this happens, they're called a red giant. After this happens, nothing is certain. What we do know is that all stars eventually run out of fuel and gravity wins. We group dying stars into 3 categories. 1. Low mass stars, 2. Medium mass stars, and 3. Massive stars. Low mass stars puff out their outer layers to produce expanding planetary nebula. Then the low mass core shrinks into a white dwarf. Medium mass stars shrink into a neutron star. A supernova happens when the neutron star is created. Massive stars burn carbon into iron. Iron takes away energy, rather than releasing it. This makes the temperature decrease and the rate of combustion increase. Just before total collapse, a neutron state is formed and resulting in a supernova explosion. Then gravity wins and nothing holds it up. A black hole is created. As I said, life of a star is hard and complicated, but very, very cool. The end.